Okay, so in this particular average speed problem, you have a junior varsity runner that left Garden Grove High School and ran east, and it states that a varsity runner left 5 minutes later or behind, running at a rate of 0.5 meters per second faster in order to catch up with the JV runner. And after running for 40 minutes, the varsity runner is going to finally catch the JV runner. And it asks us to find the junior varsity runner's average speed in meters per second. So as you practice these types of problems, the good rule of thumb, good habit is to go ahead and scan out units. I notice here the time given is in minutes, and then the rate is given in meters per second. So right away, your unit for time it doesn't match up. So convert minutes to seconds, since the question asks us the average speed in meters per second. All right, so let's go ahead and knock out a couple of conversions real quick. So here we have 5 minutes and 40 minutes. Let's go ahead and convert 5 minutes to seconds. I start with the quantities given, which is 5 minutes, and the ratio is every 60 seconds for 1 minute. The unit minute will cancel out in the numerator denominator. That will leave us with 300 seconds, and then we can do the same process of 40 minutes. So the starting point is 40, and then the conversion factor is the same, and that'll give us 2,400 seconds, which is equivalent to 40 minutes. All right, let's go ahead and knock this problem out. So here I have junior varsity on the left side, varsity runner on the right side. Again, I'll just call the junior varsity runner as object 1, the varsity runner as object 2. So let's go ahead and plug stuff in that we know and then leave stuff that's unknown untouched. Here, I don't know what the average speed for the junior varsity runner is. As a matter of fact, that is what the question is looking for. I did reduce D1 down to just D since both runners started from the same location, and again, by the time the varsity runner catches up with the JV runner, they have ran the same amount of distance. So it's perfectly okay to start leaving out subscripts when things are the same. So instead of D1, that just got replaced with just D. And then T1 is going to be 2,700 seconds. That comes from adding the 5 minutes to the varsity runner's time. So if the varsity runner ran for 40 minutes, that would imply that the JV runner has been running for 45 minutes since the JV runner got a 5-minute head start. So if you add the 300 and the 2,400 seconds, which is 45 minutes, that will give you 2,700 seconds down here. So as you can see in the statement, we have two unknowns. We're trying to solve for S1, but we don't know what D is. So we somehow have to get rid of that particular variable in order for us to solve for S1. So let's go ahead and move to the right side of the column here, or chart. Here we have the varsity runner. We don't know the average speed for the varsity runner either. But what we do know is that whatever the speed of the JV runner is, the problem states that the varsity runner is going to run 0.5 meters per second faster. So faster in this case would suggest that you take this slower speed and you add that particular value in order to get the faster speed. Okay, so this particular substitution is important. So if you didn't understand what I just said there, pause and maybe go back a little bit. And then I replaced D2 with just D. Again, the distance for both runners are the same. The time for the varsity runner is only 2,400 seconds because that particular runner has only been running for 40 minutes. Okay, so here hopefully by now you can kind of see we have S1 and D on the left side. We have S1 and D on the right side. So we have two equations with two unknowns, and we're trying to solve for S1. So we need to get rid of D. So I will go ahead and solve for D on both sides and set the two functions equal. By doing so, I can get rid of the variable D and really just leave S1 in my work. Okay, so on the left side, to solve for D, multiply both sides by 2,700. And likewise on the right side, to solve for D, multiply both sides by 2,400. But I do encourage you, as you multiply and do your algebra, use parentheses so that the algebraic stuff comes out properly. So you notice here I put 2,400 on the outside of my parentheses. This way it'll trigger that you need to distribute the 2,400 to S1 and the 0.5 meters per second. Okay, so by doing so, we can set these two functions equal to each other because they both represent D. So here's the next line that comes up. I just carry the work down. And from here, we can just distribute the right side, the 2,400 to S1 and the 2,400 to 0.5. And you should get the statement. Okay. So now all we have to do is combine like term. There's an S1 variable on the left side, there's an S1 variable on the right side. Combining like term would suggest that we need to move the 2400 S1 to the left side, which will end up making it a subtraction. So let's go ahead and do that. So taking 2700 S1 minus 2400 S1 equals to 1200, and that would reduce down to 300 S1, which is equal to 1200. And by solving for S1, we just need to divide both sides by 300, and that's it. And so S1 is going to come out to be about, well, it is 4 meters per second. Okay, I hope that helps. And if you can hear the dog barking in the background, that is my CC.